What is the stress in steel reinforcement caused by a bending moment of 65 kilonewton meter? Okay, so we have to be very careful with this one. Previously, take note that we have computed the value of the cracking moment. In this problem, we have computed the stress caused by a bending moment of 55. So meaning at the value of this moment, the concrete is still uncracked, right? Because the cracking moment is 57. So if the moment is less than the cracking moment, the concrete is still uncracked. That is why the moment of inertia that we have used is based on the uncracked transform moment of inertia. But in this problem, the bending moment is already 65 kilonewton meter. So meaning, at the value of this moment, the concrete is already cracked because the cracking moment is only 57 kilonewton meter. So if you go beyond 57 kilonewton meter, so the concrete will start to crack. Okay, so therefore, the previously computed value of moment of inertia is no longer valid for this moment because that is uncracked transform moment of inertia. But in this value, the concrete already cracked. So therefore, we need to compute a new moment of inertia that is based on cracked concrete. Okay? So again, here's the beam. So the cracking moment is only 57 computed before. Hence, at a moment of 65 kilonewton meter, the concrete will crack and we need a new moment of inertia based on crack section. We will locate again the neutral axis. So what is the difference of uncracked and cracked section? Recall, in the uncracked section, we have considered the concrete as a whole, right? So meaning, hindi natin binawasan yung concrete. Except of course dito sa butas na to na merong steel. Pero we have considered the concrete above and below the neutral axis. So meaning, we have considered the concrete in the compression and tension side. Okay, but this time for a crack section, we will no longer consider the concrete in the tension side because that is already cracked. So if that is the case, so we will no longer include the concrete in the tension side or the concrete below the neutral axis. Therefore, when determining the location of the neutral axis, so we take the moment of the elements above the neutral axis. So still that is by sub t times y sub t over 2 because this is a rectangle. And then below the neutral axis, no more concrete. So we only have steel. That is why AS times N times D minus Y sub D. Take note, there is no more minus 1 because we have not included already the tension concrete. So that is why we are only considering steel. So that is AS times N. Okay, so we substitute the value. So please solve for the value of Y. So by the way, as you can notice, it is easier to determine the neutral axis if it is a crack section. Because the concrete below the neutral axis is no longer included in the analysis. That is why the equation looks easier to solve. So please solve for y sub t. 195.710. So after that, again, we will compute for the new moment of inertia. The clock moment of inertia is determined by 1/3 by cube plus ASN times d minus y sub t. So, bakit naging 1/3 siya instead of 1/12? The formula 1/12 BH cube is used when you are determining the moment of inertia with respect to the centroid of the rectangle. For example, for this rectangle, its centroid is here at the midpoint. So, its moment of inertia with respect to this centroid is 1/12 BH cube. But take note, we are computing the moment of inertia with respect to the neutral axis. You can use transfer formula or you can use the derived formula so that it will be easier. So that is simply 1/3 by cubed if you are determining the moment of inertia with respect to a side of the rectangle. Okay, so that is 1/3 by cubed plus the moment of inertia of the reinforcement. So that is simply ASN times D minus Y sub T squared. Okay, so we substitute the value and then please compute also. In determining the stresses, so again, we will use the formula for flexural stress. So MC over I. So our moment is 65. C distance from the neutral axis towards the steel. So that is 600 minus Y sub T over I over N. Again, there is an over N because our moment of inertia is in terms of concrete. So we have to convert it into steel. Pakiulit, 195 pala, hindi 341. Okay, so that is 82.5. X, what is the stress in concrete caused by a bending moment of 65 kilonewton meter? So same question, but this time we are asked for the stress in concrete. We'll still use the flexural stress formula. At this time, we are using the distance from the neutral axis to the concrete fiber in compression. Okay? 4.96 megapascals.